This is a video explaining the quotient rule in differentiation. The word quotient means division, so we'll use the quotient rule if there is a division of expressions present in our overall expression. And the formula that we see is y equals u over v, means that dy dx equals v du dx minus u dv dx over v squared. Again, this is in the log tables, and it's a good plan to have it open in front of you in case you run into one of these. So in this question, y equals x squared plus 2x over 3x minus 1, and we want to find dy dx. So again, part of this is recognizing that we want to use quotient rule. So I can see in this question that I've got one expression on the top over a separate expression on the bottom. So I'm going to consider the top to be u and the bottom to be v. Don't forget that when we see a fraction written like this, what it's really representing is divisions. That's where the word quotient is kind of coming into things. And just like before with the product rule, I'm going to make a note of my u and my v separately, and then I'm going to differentiate each of those. So u is equal to x squared plus 2x, and v equals 3x minus 1. Differentiating u, I'm going to get 2x plus 2, and differentiating v, I'm going to get 3. Just like with the product rule, I think it's a good idea to put in those arrows again to remind you what goes with what, and then we're going to start filling it into our formula. So in this case, dy dx will be equal to v, which is 3x minus 1, times du dx, which is 2x plus 2. Watch out that in this case, this formula has a minus in the middle, by u dv dx. So u is x squared plus 2x, and dv dx is 3. This all goes over v squared, which is 3x minus 1 squared. It's important not to forget your v squared. Don't leave it out by accident. Again, just like with product rule questions, if all the question asks you to do is differentiate, you can actually stop here because you have done the differentiation part of the question. However, if the question requires you to go on and use this derivative for anything else, then you're more than likely going to need to simplify it out. Just bear in mind that with quotient rule, it's highly unlikely that you're going to have to multiply out the v squared. So in general, even if it turns out that we need to simplify on the top of this fraction, we'll leave the v squared alone. We don't need to multiply that part out. Here's another example where quotient rule can be used. We've got y equals x cubed minus 3x over root x. Again, I recognize that it's quotient rule because I've got division going on. So I label my u and my v, and I want to use those now to find dy dx. So I've written down my u and my v. Again, note the v is root x. So not really loving that. I'd prefer to write it as x to the power of a half to make differentiation more accessible, because I can only differentiate, don't forget, when it comes to indices, not with roots. And then I want to differentiate u and v to get du dx and dv dx. So in this case, du dx comes out as 3x squared minus 3, and dv dx equals to half x to the power of minus a half. Again, I would much rather take a moment at this stage to change this from indices into roots. So I'm going to just deal with that now. The half can stay as it is. Remember that x to the power of minus a half, the minus means I'm coming down into the denominator, and power of a half means that I'm rooting. And I can write this then as 1 over 2 root x. Again, as always with formulae, make sure that you have the log tables to hand so you can clearly see exactly what it is that you are filling into. And in this case, my dy dx will be v, which is root x, times du dx. Again, remember now in quotient rule it's a minus, so minus u by dv dx. And it's all going to go over v squared. In this case, that's root x squared. And just like before, expand and simplify if that's required by the question. But if the goal was just to differentiate, well, we've achieved that by getting this version of dy dx.